Hi, I'm Harley Thronson. My title is Senior Scientist for Advanced Concepts in Space Astronomy at Goddard Space Flight Center.
Why do we want to go into space and to places like Mars and beyond?
Yeah, the reasons are multiple. It depends on the individual to whom you speak. In my own case, I'm a scientist. I'm an astronomer. Space offers capabilities for our big telescopes that we can't get anywhere else on the surface of the Earth. There's no atmosphere. The thermal environment is nice and stable. You can build big telescopes that float free in space. Other scientists, Earth scientists, for example, use space as a platform to observe the conditions around the Earth and its atmosphere, the oceans and the changes in the land masses and so on. Solar scientists need to go into space to observe the sun unimpeded, unblocked by the Earth's atmosphere. There, of course, are other reasons for going into space: commercial, satellites, GPS, telecommunications, weather satellites, and so on. And then there's human spaceflight. There's the adventure of sending humans into space. If we want to carry out science programs, nothing beats having a human being on site to adjust your instruments, to replace your instruments as we do with the Hubble Space Telescope. And then there is probably a fairly solid justification for the excitement of sending humans into space, the thrill of going where no one has gone before, to see new things, to explore new worlds one day.
What are some of the best ways to get there? I understand that just sending rockets up off of Earth is difficult and maybe not the most practical, that maybe there's a way to do it from someplace in space.
Right. You're talking about libration points. So this is a little bit of a tiny tutorial on orbital dynamics. Now, we do lots of things in space. Space station, for example, is in an orbit, I think it's around 300 miles above the Earth, but it's circular. We're going around and around the Earth. Consider the following. This gets into the libration points, and they really are very interesting. If you have two masses, two objects in space, Earth and Moon, for example, gravitational field, and if they're going around one another as the Moon is going around the Earth, it happens, if you do the math, it's kind of complicated, but if you do the math, there are 5 locations called libration points, and they're very interesting. 2 of them are so-called stable libration points, and if you put something there, a rock, a telescope, it'll stay there. And that's a great place. It's relative to the Earth and Moon and travel with the Earth and Moon around the Sun. That's pretty neat. 3 of the libration points are so-called unstable. Means you have to have a little rocket on your spacecraft to hold you in that location. But that works out fine because we've been doing it for years, 30 years or so. We've been putting missions at these libration points. And again, their advantage is they're out in free space, they're away from, although they're held by the Earth and Moon's gravity, they're away from the Earth and Moon, so the observations of space, say first, we've been putting scientific satellites there for years. We plan to put some more there, depending on the purpose of the scientific satellite, and maybe one day we might put a human facility. If we are ever going to send humans beyond the Earth-Moon system, maybe to Mars, if we're ever going to send them, we're going to have to learn how to live efficiently, effectively, in free space on that long voyage from the Earth to Mars. The next step may be to take all the lessons that we've learned on the space station and apply it to a much smaller volume. We really can't send something as big as the space station all the way to Mars, where the closed cycle life support systems and the communication systems and the power systems need to be much smaller, more efficient, more reliable than in the case of the space station. We need to try them out, all the technologies developed on the space station, in an environment or in a facility more like the type of facility that we will a future human habitation system of some kind or another. That might be just the location where we will test out the next generation of technologies that we're now developing on the space station.
Why not set up a facility on the Moon?
It could be. Now again, that depends on what you want to do. The challenge to the Moon is that if you want to land on the moon, you've got to go into its deep gravitational well. I mean, the moon has mass, it's got gravity. Landing on the moon is a challenge, very expensive, either with robots or with humans. If you don't have to go down into a deep gravitational well that you would have to fight your way out of with a rocket, then no reason to go to the lunar surface.
So what sorts of vehicles would be launched from L1?
Once again, it depends on what you want to do. Because you don't have to go out of you don't have to pull yourself out of the deep gravitational well, you can use more efficient engines, rocket engines, than you need to use if you launch out of the moon's gravitational well. If you have to launch yourself out of the moon's gravitational well, you would use a chemical, I mean, the kinds of rocket engines that most people are familiar with, all the fire and smoke and stuff, because they are powerful, and you need that kind of power to move you out away from the moon. On the other hand, if you're in a libration point, you're away from the gravitational well of the moon, it takes very little thrust, very low thrust, to move you around. Quite literally, almost a human breath will move you around slowly, very slowly, and it takes time. But if you have an efficient engine, which we do, so-called electric propulsion, you can move very effectively out of libration points. So I think we've put together with these various technologies and asking the tough questions about why really is it that you want to go there. A plan is being developed by NASA, good solid debate as to whether or not it's the right plan, it's the affordable plan, you've got the right pieces and so on. But a good plan is being developed by NASA over this coming year to lay out the future of human spaceflight. Maybe as I described, or maybe another alternative. But it's a good debate to have, and it's a very exciting time.